Assalamu alaikum. How are you, my dear students? Hope you will be fine and okay. I welcome you all into my today class. Today is our lecture number third. Today is our lecture number third. In today's lecture, we will learn about atmospheric pressure, measuring atmospheric pressure, variation of the atmospheric pressure and weather. So let us start with the name of Allah Almighty. Bismillah ar-Rahman ar-Rahim. Atmospheric pressure. What is atmospheric pressure? Class, you know that the earth is surrounded by a cover or a blanket of air. That cover or the blanket of air around the earth is called atmospheric pressure. The cover or the blanket of air around the earth is called the atmospheric pressure. It is called the atmospheric pressure. Now, this blanket of air, this is formed by what? This is formed by various gases, such as, for example, oxygen, nitrogen, helium, carbon dioxide, etc. So this blanket of air that surround our earth from all sides is called what? It is called the atmosphere. The one which you see here in this diagram. Look, see here in this figure, this is our earth, and you see this earth is surrounded from all sides by what? That is the in the white shade which you see, that is actually what? That is the blanket of what? That blanket of the air, right? That blanket of the air extends to the point of roundabout, that is that it is uh, I'm so sorry, I've forgotten the exact height or altitude to which this lasts, right? You may refer this or see in a Google that what is that height. Now, this blanket of the air, but it which forms the atmosphere. I don't remember the exact figure, but I would like to tell you that extends to few hundred kilometer. What? To few hundred few hundred kilometer around the earth. So it means that we are living under the bottom of the air, like you just see that it is a kind of ocean for us. Okay, this the density of the atmosphere is not uniform. Remember, density of what? The density of the atmosphere, the atmosphere is not, it is not uniform. It is what? It is not uniform, and this decreases with altitude. Decreases with what? Decreases with the altitude. It decreases with what? It decreases with the altitude. Why it decreases with the altitude? Because as you go up, right, then what happens? The air become that is at the near the surface of the earth at sea level. What? At sea level, the at the sea level, the air layer is thickest, right? And to some kilometer it is thicker, and then it is to few kilometer it is then thick, right? And as you go up and up, it becomes thinner and thinner and thinner until it vanishes. So this is one of the reason that the atmospheric pressure, it changes with it change in the altitude. So decrease in increase in increases with the increase, that is decrease with the increase in altitude, with the increase with the increase in altitude. And this increases, that is atmospheric pressure increases with decrease in altitude, with decrease decrease in altitude. In what? In altitude, right? Because the air thickness decreases. Then when I teach to you about the variation of atmospheric pressure and altitude and its effect, then I will explain it to you there in great detail. The next important point is that, as I told you, that this is what, that the density of the atmosphere is not uniform. So non-uniform density around the earth, what that is the few important characteristic of the atmospheric pressure. The one, non-uniform density, non-uniform density around earth, right? Second, acts in all direction. It acts in what? In all direction, right? That is, and it, that is atmosphere exert pressure, and atmosphere like exert what? Exerts pressure, right? And this pressure is effect in all direction, and I will demonstrate it to you how. For example, look at the look at what? Look at the this balloon. Look at this balloon. This is the best example I would like to explain to you. Inside that, as you inflate the balloon, there is pressure inside it, and that pressure acts in all directions. So if I ask you a question that in which direction the balloon get inflated, then your answer is certainly what? Certainly in all directions. So atmospheric pressure acts in all direction, right? So and the air exert pressure on the balloon in all direction. Similarly, this is what? Uniform expansion on all side, as you see here. So there is what? There is an external pressure also, right? That external pressure rightly opposes what? The internal pressure. This is why as you inflate the balloon more and more, you will feel difficulty by putting more air into it, right? Because the external pressure also increases on it. Now there will be a point when the internal pressure in the balloon, internal pressure, when this internal pressure becomes greater than external pressure, then what happens? The external pressure is that from what? Atmosphere, atmospheric pressure, right? And this is what? The inside pressure. Then the balloon, it will what? It will burst, right? It, or explode into a pieces. Similarly, the air pressure inside the bubble, the soap bubble, is equal to the atmospheric pressure. This is why how the soap bubble keep its shape. How does the soap bubble keep its shape? And this is the reason that the interior pressure inside it is equal to what? It is equal to the external pressure, right? And because of this reason, due to this external pressure and the internal pressure, when they are equal, then this causes the soap bubble to maintain its shape, right? And so this is all about what? This is all about the atmospheric pressure. And now there is another important experiment And this experiment is what we call the crushing cane experiment. What? Crushing cane experiment. This experiment demonstrate that atmosphere exert pressure. What? Atmosphere exerts pressure. Atmosphere exerts what? The atmosphere exert pressure. This is what we will explain in an experiment known as the crushing cane experiment. Crushing cane experiment. You may choose any tin cane, right? 10 cane, an empty 10 cane, like the one which I show for that of 7-Up or the Pepsi or any other 10 cane, right? Take the empty cane, and when you take the empty cane, fill the empty cane to some level, right? To certain level, like the one is shown. This is the level of what? The level of the water in the empty cane. Now you know that this that is that there is air all around it, as you see, right? And you know that this air, the external air, it create pressure on what? It create pressure on the water surface, pushing the water downward, right? So as you see the air molecule inside it, now you place it on the burner and starts heating it until it starts boiling, right? When it begins to boil, then what will happen? Steam will form. As you see the steam right here, this is what? This is the steam. I mark it already. So you see that what will happen? The steam will cause the air above the water surface to push outward. This air is then expelled, right? And when the air is then expelled, all the air is expelled. Now you remove it from the burner and quickly the place the cape on the cane, right? So tight cape it, right? Now pour cold water on what? Cold water on the water cane now, which are boiling. Suddenly, what will happen? That the air above it, right? That is the sorry, the steam above it will suddenly condense. When it condense, it will change into water, right? And will fall into the remaining water like this, okay? And what will happen, right? That above this there will produce what? A low pressure area. What? A low pressure zone. We can call it, you may say, the vacuum, right? And this pressure is very low inside, right? The pressure is what? The pressure is very low inside. Now you see that there is no air inside it, so the pressure, that is very low pressure, there is almost vacuum. And here is the external pressure. Now you see that the external pressure is what? The external pressure is greater than what? It is greater than the external pressure. And what does it means? It squeezes on what? Or it crushes on the, it crushes on what? It crushes on the tin cane, and the tin cane squeezes into the kind of shape which you see. So this experiments demonstrate that uh, atmosphere exert pressure. Now the question is that how to measure the atmospheric pressure. Atmospheric pressure can be measured by a device we call barometer. Measuring atmospheric pressure. Measuring what? Measuring the atmospheric pressure. Now, the atmospheric pressure can be measured by a device or instrument called barometer. It is called what? It is called barometer. A simple kind of barometer is shown in the figure here in your front. It consists of the, if you see, look, it consists of the mercury, the mercury trough, right? In a, as you see, and there is the glass tube. There is what? There is a glass tube such that the glass tube is closed at what? It is closed at one end. Closed at one end, right? And it is open at the other end. This is the open end of the mercury tube. Open end. It is not, first, it is not there. It is just outside the tray, and it is 100 meter and what? It is 100 meter and, oh, sorry, I'm very sorry. 100 centimeter, 1 meter. It is 1 meter in length or 100 centimeter in length. Clear? Now you see that it is all filled. First, it is all filled with what? This is all filled with the, it is all filled with the mercury, right? As you see, like this one. Look, it is filled with what? It is filled with the mercury, right? So that no gap is left. Now take this mercury filled glass tube and invert it into the glass tray. When you invert it into the glass tray, then because of the gravity, the mercury in the glass tube will descend, right? It will come down, right, into the glass tray. Now you just see there are two things that is acting. First one is the pressure that is created by what? The pressure which is created by the mercury, right, in the downward direction, as you see. So there is one internal pressure. That internal pressure is caused by what? It is caused by the mercury as it falls down. And then there is the atmospheric pressure also. You see that the atmospheric pressure, it is acting what? From all sides on the mercury in the mercury trough, right? Pushes it downward, right? So as it find its place, it will be trying to squeeze into what? To squeeze into the glass tube. Now you see that, look, the two pressure at one point, that when the internal and the external pressure will balance each other, then what will happen? The fall of the mercury in the glass tube will fall. When what? When the internal, what? When internal pressure, when the internal pressure, and this internal pressure is due to what? Pressure due to mercury, due to Hg, when it equals the external pressure. And who is causing this external pressure? This external pressure is because of the atmosphere. When these two equal, further descending down will stop and the mercury will stay at a certain reading, right? This all happens, remember, I'm sorry, I might told you this thing first. This all happens at sea level. At sea level. Now why sea level is chosen? Sea level is chosen because that is the lowest, what? The lowest depth, right, position. So that is taken as a reference point. And of course you see that the air is thickest at the sea level, therefore the pressure will be the greatest at that point. So this is why this experiment is done there. Right now, look, you see that the mercury will stop at a certain point, the calibration, right? The reading where the mercury stop is 60 millimeter of Hg or 760 centimeter or zero point 0.7 meter. It stops there. Clear? What does this shows? This is called the, we call it what? We call it the atmospheric pressure, that at sea level, at what? At sea level, the atmospheric pressure, the atmospheric pressure is 760 millimeter or 760 centimeter of Hg, right? In order to make it more meaningful, we measure pressure in what? We measure pressure in Pascal. This pressure is equal to, in Pascal, and this pressure is what? This pressure is 101 into 300 Pascal or Newton per meter square, or simply we can say 1.01 into 10 to the power 5 Pascal, or zero point 0.1 megapascal we can say, right? How they came across this equation? In the next lecture, I will be deriving to you the kind of equation where I'll be telling to you the pressure exerted by the liquid. It is calculated by the formula that the pressure exerted by the liquid at any point depends on the density of the liquid, the value of gravitational acceleration, and the depth to which it acts, right? So we know that as we are using the liquid as mercury, so density of mercury, right? Density of what? Density of mercury. We know the value of G around 9.8 or 10 meter per second square for you, and the depth you now see 0.76 meters. So when you make all these calculation by knowing the density, you can refer to your book to know the density of what? The density of the density of the mercury. I think it might be around like mm, wait, let me call it is around about, I think, 1306 30 13600, you may say, kilogram per meter cube, right? Or you may say that it is 13.6 times denser than the water, and the water density is, of course, everybody remember, because this is very much universal, 1000 kilogram per meter cube. This is why we do not, yeah, we cannot use the water barometer. Why? Because for the water barometer, since you know the water density is very less than the density of what? Than the density of the mercury. So in order to have the water barometer, you might be having a very long tube of water, around about 10 meter, which will make your barometer out of proportion. This is why water cannot be used in, as a barometer, right, to calculate the pressure at any place. So this is all about barometer, and this is how we use the barometer to calculate what? To calculate the atmospheric pressure, right? Now, as I told you before also, that the variation in atmospheric pressure. So the variation of what? Variation of the variation in what? Atmospheric pressure. The variation in what? In atmospheric pressure, right? As I told you, that this variation in the atmospheric pressure is like the atmospheric pressure decreases as we go up, or it decreases with increase in the altitude. And the atmospheric pressure, this is one of the reason that the atmospheric pressure on the mountainous area is very much smaller than at the sea level. This is one of the reason that you are living in Taif, then you have a very less pressure here, because the air layer is very thin at the Taif, because it is at a greater altitude than Jeddah. But at Jeddah, it is all okay. The pressure is greater than at the Taif. This is why even sometimes the people feel difficulty, right? Why? Because we have less oxygen here, although it is not that much, okay. you should not take it seriously, but still it is less, not that much less, but less. Similarly, in Pakistan, you compare Karachi and Murray, then of course in the northern areas or in the Murray, the pressure will be less than at the sea level, right? So that is roundabout at the height of 30 kilometer, this pressure falls to 1000 pascal, right? Okay, at what? At 30 kilometer height, the pressure becomes what? Almost 1000 pascal. So you just see this is very, very small pressure, right? So increasing altitude, decrease the pressure. This effect is used in measuring what? In measuring the altitude of the aeroplane. We can measure the altitude of the aeroplane by calculating the pressure acting on the aeroplane there, right? And how you can calculate this, the height or the altitude. Pressure there and density of the liquid which measure this and the value of G, right? So this describes your altitude. So by knowing the pressure you can calculate the altitude, and by knowing the altitude you can calculate the pressure at the given place. So this is why it is one of the most important aspect or point. Similarly, this is very, very important also in the case of what? The in the case of atmospheric pressure and weather. Atmospheric pressure and weather, right? And that is weather changes can be the cause of change in pressure. So when pressure changes, it's certain or particular place, the weather also change, right? For example, look, you just see that at the area that is at the hotter region or on a hot summer day, what happens? The pressure falls. The pressure what? The pressure fall. Okay. Why the pressure fall? Because you see, look, what is the pressure? As I told you, that rho g h. Later on inshallah I will derive this equation. And now you see, what is density? Density is equal to mass per unit volume. So now when the day is hot, so the surrounding gases will expand. When it expands, its volume increases, density decreases, and the pressure decreases. Similarly, on a cold night, the reverse occur, right? Pressure increases. Why the pressure increases? And that is the volume of the air decreases, the gases contract, volume decreases, density increases, and the pressure cause. And this bring weather changes. And this bring what? This bring weather changes, right? The decrease may be sudden, the decrease in pressure may be all of sudden, it may be gradual, the decrease, there may be sudden increase, there may be gradual increase, right? So they can cause the pressure changes. So the changes in atmospheric pressure at a certain place indicates the expected weather condition, right? For let me give you one such example. For example, the gradual or the average drop in the atmospheric pressure at that very particular place means that there is low pressure in that region. A minor but rapid fall in atmospheric pressure indicates a kind of windy or showery conditions, right? So these are all related to what? Related to the pressure changes. For example, a sudden atmospheric pressure is a sudden fall in the atmospheric pressure is very dangerous. Sudden fall, if the atmospheric pressure at certain place called certain place suddenly fall, then what will happen? It will become the cause of storm, right, or typhoon, etc. So this that is caused by sudden drop in pressure. It is caused by what? Sudden drop in the pressure. On the other hand, that if increase in pressure is detecting also the intense weather conditions, predicting, right? If there is a gradual large increase in the atmospheric pressure, it brings a very pleasant weather there, right? Or rapid increase in the atmospheric pressure may cause that it may you may say that a rapid increase in atmospheric pressure may be indicating a poor weather condition. So it all because of this relationship, right? The P inverse relationship, V, right, like that. So this is all about our today lecture. Hope you might have learned a lot from our today lecture. That is that what is atmospheric pressure, the variation of atmospheric pressure with altitude, the measurement of the atmospheric pressure by using a device called barometer, and the expected or the predicted changes because of the drop in the atmospheric pressure. You have also learned this. Inshallah, the next lecture will be more important, and in that lecture, you will be learning the pressure exerted by the liquid, like this equation as you see, right? Sorry, this one. Clear? So, this is all for today. Thank you very much.